Let's talk about voltage followers. Voltage followers, or buffers, are all over the place, but what are they and how do they work? They're actually one of the most basic op-amp building blocks. They just take whatever signals at the input and pass it on to the output. But why would you need something like that? Why not just take your signal and pass it on to the next stage of your signal chain? Most often it's because of impedance. Your signal source might have a really high output impedance, which will cause loading effects. If you don't know what loading effects are, you can check out the loading effects video in this op-amp video series. Voltage followers effectively eliminate loading effects because they have a really high input impedance and a really low output impedance. So basically it's like an impedance converter. Buffers are also good for current amplification without voltage gain, driving capacitive loads, and improving response times. So let's use Microchip Mindi Simulator to show you how they work. Okay, we'll start by adding an op-amp and we'll change it to the MCP6006. It's a really good general purpose op-amp. And the way you configure a voltage follower is by connecting the inverting pin to the output, and the non-inverting pin is your input signal. So I'll add a voltage source there. We need to power our op-amp. So we'll just do a single supply. So I'll have it at 5 volts and we'll set this pin to be VDD. And it goes here, and then VSS will be ground. And then we need to add some probes to the output and to the input, and that is our voltage follower. So let's test it out. What happens if we put in a 1 volt DC signal into it? Let's go to Simulator, choose Analysis, pick Transient, and push Run. Let's see how it does. Okay. We have our input signal in green, looks good, 1 volt, and our output signal in red, 1.000291. So that little offset is from the op-amp, the offset voltage of the op-amp, so that's normal. That looks good. Okay, let's try something a little more complicated. Let's make it a sine wave. Let's click sine here, push OK, and push Run. Okay, so we can see that the output is following the input up until here. What's going on? So first of all, we need to understand the dynamic range of our op-amp. The MCP6006 is rail-to-rail input and rail-to-rail output, meaning you can input a signal anywhere between the rails, so between ground and 5 volts, and you can output a signal anywhere between ground and 5 volts. The problem is that our input signal is from 1 volt to -1 volt. So from 0 to -1 volts, we are not within the dynamic range of the op-amp. So how do we fix that? Typically what we'll do, because we have a single power supply, is we will give our input signal some offset to shift it to be in between, kind of right in the middle of our power supplies. So we'll give this offset, we'll say 2.5 volts because that's half of VDD. And let's give it a shot. Okay, so that looks good. There's no clipping. The output follows the input, and it does what a voltage follower does best. So there's another option we could have done. We could have, instead of using a single power supply, we could have done a dual power supply, and that would basically shift our dynamic range down. Instead of from 5 volts to 0 volts, it could be, let's say, 2.5 volts to -2.5 volts. So that would be our -1 volt to 1 volt would be within that dynamic range of our op-amp. So that would have been an option we could have done, but that's not a very common approach that people take. So single power supply, we shift it up with this offset. So that's about it for voltage followers. If you're unfamiliar with them, I highly recommend playing around with them in Mindi Simulator to just see how they work. I've provided an already built schematic in the links below. Check out the other videos in this series to learn more about op-amps in general. Thanks for watching.